Alright, time for me to bust out the excuses as far as this going on today. And again, it's a hard day, and that's the first thing I'm going to use for excuses, but there is no excuse. I'm just reading the charts. Mu electron
Thanks
instead
to
of electron,
CuriosityStream for
W boson.
supporting PBS Digital Studios. Since the discovery of the
It's
Higgs boson,
Heliosy.
physicists have searched and searched for any hint of new particles. That search has been fruitless until to your butts. This points to sterile
Maybe I could say I'm a
neutrinos.
mu electron.
Hold on to your butts. First, the standard model of
mu-
particle
muon
physics.
change.
As we'll see in upcoming episodes,
Okay, thank you, Spacetime Guy. I'm going to need this for a minute. You just give this to me. What I'm doing is that Schrodinger's circular or spherical trigonometry, using astrology north, the Big Dipper, or the Big Bear, as a photon of its gluons. And as you can see, the standard model says Higgs usually hits. Z boson, the electron, me reading the charts, that makes me a low energy state, makes me a fermion, boson, makes me a boson. And amongst bosons, there's an order. There's high and low. Z boson was actually a guy's name. The W for it is his low state of a situation. Higgs usually writes out the paperwork, and it's generally when you see them out there doing the Brickengyre conjecture or twistor theory that's when you can kind of tell. Overall, that was down between start to finish. Love the talk on Compton scattered and helici of this thing's orbital as it's kind of going through there. It says, I'm reading the charts this morning, the tea leaves. I don't know enough about this stuff, so I'm definitely trying to figure out science in general or this Hadron Collider. But I come in and I come in fast. I'm a fermion amongst those states. I'm not really the person that come up with the math, and I'm not really the tester out there doing it in the field. When things are down, generally that's where you need the photon the paperwork, the inverted square three-phase. You got to figure out the dot plot before you have a dot plot. F1 plus F2 equals minus F1. And that's how you IH that distance or time or model thereof about what that is, and then you're going to start calling them out with better certainty. And that certainty works like a Higgs collision or a particle. When they're up in the helice, this one's down. This one's moving left-handed spin because it's programmed, and that's what's up. Those charts will invert the whole thing backwards like that. If this one's spinning this way, same weight, same element, hydrogen, and I put this one this way against gravity, the number had changed. The charges or maybe the magnetism, if there was a phase order to that, that is mathematically why those distances are there, because otherwise you're just getting lucky on the Higgs, right? These are charts. I am flat or N1 half, 0 for the days. I'm staying in those 12s and things like that. Hopefully I can make that back in a day or two, but it's not in there with those $100 day or at least $25 point days on my charts, and that's overall the whole Hadron Collider as far as it's designed in parameters to say that that's what that does. And if that bumps me up a little bit better here, then that's kind of what I'm looking like. I got that fuzzy bunny on me. It's the Mewtwo melting somebody about the 100th position on that as some wave operator maintenance service thing on a skid steer saw, right? That might catch Higgs about, wow, that's a great hidden variable. The Mayan astrologists that before the kid came up, Feynman, they're the kid one that talked about the orbitals. I never knew that. I was doing astrology. Its trigonometry is fantastic. But as far as the correlation in itself or which field it's in, am I correct? Is that really something that's right inside of what it does? Because you'll see people up and down in their head, or that up and down carries another momentum as far as being strange to it. They are nodding up and down, and they shouldn't. And or because of the TED Talk lecture, that is a mathematical trigonometry, and people didn't question it. They said 0, or they clapped and applauded. Now, that's supposed to be on a charm. Clap. Everybody loses it, right, and starts clapping, or they start booing you. Or one of them boos and then they all start booing you. You misgauge the 100th or the 10th, the 100th or the 1000th position in base 3 like that, which is an offset oscillator. It's still bumping, but it was my first move. It was this one and I still caught this, and I played that. I didn't get wrecked on a double operator in some way that made me look like a W boson, because, after we get them all, we get all those collisions throughout the day. We got the IMA players running the 20, and that's all they do. That's the limits of that standard. Whatever, how many other variables you can run to think about. One stock, it dropped, you split it, put it back down, grinded it out, made sure you covered your losses. Good way to play it. It was dropped, you sold it, moved to another stock, it climbed, and just covered it in the timeline. All of those are correct diagrams, but they have market potential at that point in time to list it as the paperwork photon, here's the proof, or if NP, easy to check, easy to look up, let me perform that action or give you a simple physics that would describe in these new numbers what that state is. And in general, you'll have, beyond that point inside of that line, the tenths, the hundreds, the thousands, some basic maths, and yeah, there's, even though you got the regular optics up and down, they're not very precise on it. It's a little bit more precise before you get to up and down range. The absolute zero limit, negative 273 Kelvin, negative 272 Kelvin, 2.999 to 1 Kelvin, 271, 270 Kelvin, but also 72.9999, 799 infinity, wherever you want to cut off of that decimal where it matters, Fed funds rates and S&P 500, or something that's going to say, well, individually, these lines, not me, but Q and P so close, who wore it better, wouldn't really matter in that field. If Z boson is down there grinding it in the office or on the saws, then I expect that type of same result in the office, right? Against something else, you have friction, reluctance, and those are indicators of certain things, almost like a mechanical action. You pour salt on it, and the chemical reaction, and well, anyways, catch you on the next one.